Let's discuss geometry and some topics related to geometry. So in order to discuss about geometry, first we have to discuss some basics of geometry so that we can excel in geometry. So the basics are so important, right? So firstly, let us discuss some important basics so these are our topics to discuss today. So let us discuss the first one. What is Sevian? When we solve the problems in geometry, we are in the most of the cases we have to discuss about we come through triangles, right? So in any triangle, any line drawn through any of the three vertices of the triangle is known as Sevian. Any line. This is Sevian. So, based on this Sevians, we have Seva's theorem, and we can discuss later. Let us go to another topic, another subtopic. What is median? Median is also a Sevian. Drawn through a vertex joining the midpoint of the other side. That means BD is equal to DC, right? So in the median we can draw three medians. That is right. Start. Okay, we can draw three medians. The point of concurrence of three medians is known as a centroid. It is generally denoted by G, and the centroid divides the median in 2:1 ratio. 2 parts towards vertex, 1 part towards side. I mean, AZ is to GD is equal to BG is to GF is equal to CG is to G is equal to 2:1, right? 2:1. In order to prove this, what is this statement? Let us go to the topic. See, now I would like to discuss the most important, it's like a trick, and it's like most important point. Okay, in a triangle, if we draw any Sevian, we can tell one thing. Okay, suppose area of ABD by area of ADC will be BD by DC. Now let us prove this, because if we draw altitudes in a triangle, in acute angle triangle, the altitude will be inside and it will be like this, right? And if in an obtuse angle triangle, if we want to draw altitude from this vertex, from the marked vertex A, we have to draw outside. We have to produce BC towards B, right? So this will be the altitude. And in right angle triangle, the side itself is altitude. So this is altitude to BC. Okay. So now coming to this particular statement or this particular theorem. Now let us discuss this ABC AD. So if it is acute, then definitely it will be obtuse, or else if it is acute, then definitely this would be acute. I mean, these both are acute and obtuse angles, because their sum should be 180. In order to make the sum as 180, one should be acute and one should be obtuse or equal. So now let us draw an altitude named as some AM. We can by these three diagrams, by the scenario what we saw in the case of altitude, we can tell that triangle ABD and triangle ADC having common altitude, right? Because one will be obtuse and one will be acute, because so these both will have same altitude. Since they are having same altitude, their areas, what is, we can tell the area as half base into height, right? When height is same, the area depends on base, and the area is proportional to base. So we can tell that area depends on base, and area's ratio will be the ratios of their bases. Let us discuss in clarity. So area of triangle ABD is equal to half of AM into BD. In the similar way, area of triangle ADC is equal to half of DC into AM. So this is the ratio area of triangle ABD by area of triangle ADC is equal to BD by DC. I think you got my point. In any triangle, when we draw a CV1, to a base, then definitely these two areas will be in the ratio of the length by which it is divided. These two areas will be in the ratio of BD by DC, right? And in similar way, these two areas also will be in the ratio of BD by DC. Similarly, if we close this triangle, okay. So now let us prove how the centroid divides the median in the 2:1 ratio. 2:1 ratio. Okay. Now, if we take a triangle and draw three medians meeting at a centroid G, now let us see. Okay. So, since it is a median BD equal to DC, and we can say CE is equal to EA, and AF is equal to FB, like that. Okay. Let us assume that area of triangle PGD is equal to some x. Let it be some x. When it is x, this should be x. Since these two areas will be in the ratio of BD by DC, which are equal. BD by DC is equal to 1. So area of triangle BDZ by area of triangle GDC is equal to 1. So these two areas should be equal. In the similar way, let it be Y, this should be Y. Let it be Z, this should be Z. And since this is a median and this is a CV1, so and BD equal to DC. So this total ABD, area of triangle ABD, is equal to area of triangle ADC. So x plus 2z is equal to x plus 2y. We can say that y is equal to z. In the similar way, area of triangle ABE is equal to area of triangle BEC. So y plus 2z is equal to 2x plus y. That implies that x equal to z. So from equation 1 and 2, it is, we can simply tell it as y x equal to y equal to z, right? So we can tell it as the triangle can be written as we can draw it as x x x x x x. So this is G D E F. So now AG by GD, AG by GD will be in the ratio of, now let us see this triangle, and this is a C1. This should be in the AG by GD should be in the ratio of area of triangle AGB by BGD, right? Area of triangle AGB by area of triangle BGD. So that is 2x by x, 2 by 1. So AG is to GD, 2 is to 1. Similarly, BC is to GE, CF, CG is to GF. These all are 2 is to 1. Okay, so we proved that in a triangle the centroid divides the median in 2 is to 1 ratio. So this is we need not need proof, but the scenario what we did in the proof is so important, and this particular statement is so important. We can use it in many problems. If we know it, it will be useful. Definitely it will be useful, and it is one of the theorem which is so rare, but it is so important. So we completed CV1 and median. Let us know what is altitude. It is familiar. What is altitude? Altitude is also a CV1 drawn from a vertex such that it is perpendicular to the other side. So altitude is also a CV1 which is perpendicular to the other side, and how it divides the other side. So as it is B, it is angle C, and so this is angle B, angle C, and this is A, and we know this is small c, this is small b. So some by trigonometry in triangle ABD, we can tell that let's apply cos B. When we apply cos B in triangle ABD, it will be BD by AB, that is BD by C. So BD is equal to C cos B. Similarly, in triangle ADC, DC is equal to B cos C, right? So we can write BC is equal to, okay, we know that BC is equal to BD plus DC. So that implies that A is equal to B cos C plus C cos B. This is what projection formula we learn in properties of triangles. Okay, now let us go to another one. What is perpendicular bisector? What is perpendicular bisector? Oh, I forgot one thing. The point of concurrence of altitudes is known as ortho center, and it is generally denoted by H. And what is perpendicular bisector? Perpendicular bisector is not a C1, not a C1. Perpendicular bisector need not pass through the vertex of the triangle. It bisects perpendicularly to a side. It refers to a side. Perpendicular bisector refers to a side. It does not refer to the vertex. And point of concurrence of such three perpendicular bisectors is known as circumcenter, from which it is denoted as circumcenter is denoted as generally denoted as S. We can tell that AS is equal to BS is equal to CS. So taking these three as radius, we can draw a circle passing through the three vertices of the triangle known as the circle known as circumcircle. And similarly, let us discuss what is angular bisector. Angular bisector is a C1. Angular bisector is a C1. It divides the angle equally. It bisects the angle, so it is known as angular bisector. And point of congruence of such three angular bisectors is known as in center, and generally denoted by I. And perpendicular distance from in center to each side is same. I mean from I, let us draw three perpendiculars to three sides. Those perpendiculars should be same. Let us name it as PQR. IP equal to IQ equal to IR, which is equal to small r, which is known as in radius. Small r is known as in radius. Taking it as radius, and in center as center, we can draw a circle which just passes through the three sides of the triangle. It is known as such a circle is known as in circle. And let us go to some important tricks, like it's like theorems related to circle. In a circle, if we draw any two chords, let us name it as AB and CD meeting at point O, we can tell it as AO into OB is equal to CO into OD. AO into OB is equal to CO into OD. We can prove it. By so short. So joining these four, this is a cyclic quadrilateral, and comparing triangle AOD and triangle COB, these two angles are vertically opposite angles, and these two angles are equal, and this is alpha, because these two angles are in the same segment, right? They are drawn from the same chord, like this. So alpha equal to alpha, vertical opposite angles, angle AOD is equal to angle COB, and angle ADC is equal to angle CBA. So by AA criterion of similarity, we can tell that triangle AOD is similar to triangle COD. So we can tell as AO by CO equal to OD by, and so this is B, so OD by, this is OB. That implies that AO into OB equal to OD into CO. It is proved. So similarly, another one I will not prove this. We can prove it. So this is, if we draw two PAB, two chords from an external point, now we can write it as PA into PB is equal to PC into PD, right? This is also one of the important. We can discuss this proof later, um, probably in circles, and similarly we can it as PT. Here this theorem comes it as PT square is equal to PA into PB, because here C and D coincide, so we can write it as PT into PT, so PT square equal to PA into PB. This is also important theorem. These three theorems are so important, and these are what we discussed today. These are the topics which someone feels that these topics are somewhat rubbish, but these are some important topics, and these are the proofs where which are so useful, where we can use in problems, we can use in some problems. So these proofs and this scenario what we did will be very useful in the problems, and the kind of thinking we did in these problems and what we constructed, and these are so important. These three theorems are so important, and later we can discuss problems based on these some what we discussed today, and probably in the next class we can jump into the geometry related topics like pure geometry. Up to now we discussed fundamentals. That's it. Okay friends, this is my first video in YouTube. If you like the video, do like, share and subscribe, and tap on the bell icon for some more updates. Feel free to ask doubts in the comment section, and let me know in which topic you have doubts, and let me know in the comment section, so that I will try to know the topic if I don't know, and I will try to explain as good as possible, and I will try to explain as deep as possible. Thank you friends, please do like, share and subscribe. Thank you. That's all for today.